All right. Where is Zoom? Here's Zoom. Good to see everyone. I guess I don't actually get to see you, but that's all right. We are doing this week analysis of acetic acid, volumetric determination. Now, what's important to realize is we're actually skipping a lab. So our most recent one was the phosphorus fertilizer one. We're skipping this page 41 lab and going on to page 40, 45. Page 45 is the next lab. And let's go over some announcements from Dr. Christofferson first. So there was a grading point distribution mistake on the fertilizer lab. I guess there just weren't enough points assigned to it. So for your fertilizer labs, all the grades are going to be multiplied by 1.7 and rounded to the nearest 0.5 to correct for that. So there's that general thing. And then for this lab here, I just want to start off by saying that this is a very common lab. And there's a good chance that if you took high school chemistry, AP chemistry, something like that, you've done this exact thing. And a lot of what I'm going to go over is going to be totally boring. And unfortunately, I still have to make this whole video. But at the same time, if you have never done a titration, this will be a long video, and I will recommend sticking through it to just try to understand as much as possible what is happening. Because I realize there's a lot of people who haven't had chemistry ever, hadn't had a chemistry lab ever, or it's been a super long time. And then you have people that recently took it. So if you've recently taken it, the key things to take away is that we're going to cover the stuff on page 45 for the lab, but also page 83. There we go. Appendix B, where it's going to go over some techniques for performing a titration of a burette. And when it comes to knowing figuring out what do you have to know in order to be prepared, well, you have to know how to do the calculations for this. And so I want you to be prepared to do this. That also means I'm going to quiz with this in mind, being like, okay, how can I prepare them for that? For safety, there isn't really much safety. We're playing with vinegar, so there isn't much to prepare for safety. So therefore, there isn't much to quiz for safety. But then technique is going to be very, very important. And knowing the correct terms to use when talking about this, understanding what's happening. And so that's why you also need to understand page 83, and it references that in the lab somewhere. That's how I found out that there was even an appendix, is because I was like, oh, let's go look at this. It's very useful. It's got several different terms that are italicized: titration, standard, analyte, burette, titrant, equivalence point, indicator, end point. There's this paragraph here. You don't need to know that because our sodium hydroxide has been made for us and standardized for us. So that, just ignore that second paragraph there. And then turning the page, page 85, we have using a pipette. And again, some italicized terms to just make sure that you're familiar with. The things that we'll be using would be pipette, graduated pipette, transfer pipette. And I'm not going to quiz directly on like how many mils of this do you need and how many mils of this do you need, because when you're doing the lab, you'll have that information. But you need to be able to do the calculations. You need to be able to understand the tools that we'll be using, burettes and pipettes, and understanding the broad concepts, essentially. That's the stuff that you have to understand that you really won't necessarily have time to figure out in lab necessarily. So come prepared to understand those things, the calculations and the equipment we'll be using. All right, let's go back to my notes on what else I need to cover. Oh, slide thing. Page 88, I just learned that the pH probe was invented by a guy who lived in Bloomington Normal. So they have that in your lab manual. Has nothing to do with this lab. I just found it interesting. Also, I'm going to put out a supplemental video of someone else performing a titration. There's lots of them on YouTube. Like I said, this is a super common lab. And so for those who aren't familiar, you can watch that. And I'll also make a supplemental video going through the calculations for a single trial. I'll just make up numbers. They could be totally bogus. Like I don't off the top of my head know like how much volume of stuff, or I don't know what the percent of the unknowns are. So I'll probably just pick something common like 4.5% or something and go through this. So there'll be at least 2 more videos. One won't be of me, but it'll be of someone else actually in lab. I don't have a lab here to show the glassware. It'd be cool if I did. And then one will be of me going through the calculations. Since they're supplemental, you don't have to watch them. Like if you feel comfortable knowing what is coming, then don't worry about it. But if it's all totally new, then please watch them and they should be beneficial. And yep, so there's those announcements. And then just general info to convey from Dr. Christopherson. There's going to be 5 unknowns, A through E. I'm going to randomly give them out to students. You better record them on your lab reports and don't share unknowns. And when it comes to collecting your unknowns, they're all liquids. I mean, they're basically just different vinegar samples. And so you're going to do this titration up to 5 times. If you get 3 good results, then you don't have to do number 4, number 5. But each one takes 10 mils, which means you could need up to 10 mils. And when that means you could need up to 50 mils. And also when you're pipetting and measuring it out of your beaker that you have your 50 mils in, it's impossible to suck out the very last drop. So when I'm dispensing these unknowns and the TAs are helping dispense these unknowns, bring a container that can fit 50 mils, maybe a 150 mil beaker, or it could be like a flask or something, but it's got a 50 mil mark on it. And we're going to give you 50 mils plus a little bit extra just to, in case you have to do all 5 runs, that you can easily pipette out and that you'll have enough for the entire time. So bring a container or however we do it, but we're going to put it into a container just to fit the 50 mils. And myself and the TAs, we're going to make sure that we're dispensing these unknowns, because if they got contaminated, it would ruin the lives of a lot of other people downstream who also use these stocks. And so in general, it's good to never necessarily put things back into a stock bottle, especially if it's something that is quantitative. Qualitative, it's not, doesn't matter so much if you know it's only going to be used quantitatively, or qualitatively, but quantitative needs to be kept completely pure as long as possible. And again, this is a note from Dr. Christopherson. She's got so many years of experience. She's got so much smarts when it comes to this. And I'm sure she's seen this before. She's said that there's a hectic lab for people using burettes for the first time and pipettes for the first time. So in that appendix section, it goes over rinsing, filling, proper titration, how to do a fraction of a drop, and rinsing the tip of the pipette when you're getting close to the end point. And I'll go over all that more here in a little bit. And then it also talks about what you need to measure things to. So the burette, it's going to have marks every 0.1 mils. And so the uncertainty will be beyond that. So somewhere between, somewhere in the next digit over. So if it's to the 0.1, let me just write this so that I don't. So if the burette has marks every 0.1, then the uncertainty is in this next digit. There's various ways of doing this. I indicated that at the beginning that you could round or whatever, but the manual does say to do all your measurements to 0.05. So since the burette marks everything every 0.1 mils, your measurements should be rounded to the closest 0.05. Now, if you really want to be a pain, I hope you don't, but I was reading in the appendix B where there's a discrepancy in the instructions. For that, it says that your values should be rounded to the 0.02 mils. And again, that just comes down to the fact that this is the uncertain digit here. And, you know, we're just going to go with the recommendation to stick to the 0.05. I've also done it to just like, you just round it to whatever you think it is. If you think it's like a third of the way past the mark, then you'd put 0.0 or you put a 0.3 there or whatever. But again, sorry for all the confusion. Stick to 0.05, round it to that closest mark, since that's where the uncertainty is. Don't follow what the appendix B says, and don't follow what I said earlier on in the semester, because it makes the life of the grader easier and it keeps consistency between all the lab sections. And it matches the rubric. Don't take the stuff from the demo. I think that's my fault. I actually know that's my fault. I had a student take a piece of the demo when I can't remember what it was, but that's why that's in this reminder email. Correct color endpoint. So let's share screen. This is the video that I will be sharing. And this is essentially what it's going to look at the endpoint. You'll be able to see this link and be able to watch the whole video for yourself. But you can see it starts off as color liquid and phenolphthalein is the indicator. We've used it before. It turns pink, really close to pH neutral. And so when you finally, add enough in, boom, that's the color right there. And again, I'll share this video so that you can watch not just the color, but the whole process. And it goes through some of the calculations too. Zoom, stop share. And my notes. We'll be providing the 10 mil volumetric pipettes for the acid. And it's good idea to practice using DI water. If you've used volumetric pipettes and bulbs before, then I have no problem with you being like, I've done this so many times, I'm just going straight to it. But if you've never done it before, try it first with DI water. And I might actually amend that. While the suggestion is try it first with DI water, one of the things that you have to do to make sure things are clean is to rinse things with the solution that they're going to be in. In fact, that's what it says in Appendix B. And so I would change this note here to actually say, practice using your unknown. And I guess this means you actually have to take more than the 50 mils if you're going to practice taking out 10 mils and then just dumping it down the drain. But if you try filling a volumetric pipette 3 times, that means any dirt or water or prior chemicals that are in them will have been rinsed out 3 times with the chemical that you'll be using. And that'll make it really, really clean and really, really good for the stuff that you're doing. So instead of practicing with DI water, practice 3 times with your unknown at filling it up and then just dumping it down the drain. And that's exactly what it says in Appendix B, which means we're up to like 80 mils dispensing of the unknowns. Oh well. And I'll probably stick to 50 and just hope that you guys don't mess up too many times, or 60. And we can get you more if needed later. But that way you're practicing and cleaning your pipette at the same time, instead of practicing and then having to clean and then finally doing it. Return the pipettes because they're going to be needed for the other lab sections. And this is the part where, depending on how good your results are, will depend on if you have to do multiple runs. You have these 3 different runs here. And the note from Dr. Christofferson is, after you complete the titration trials 1 through 3, you'll look at your endpoints and you'll compare them, and to see if the endpoints are within 0.20 mils. And that's 0.20 mils. So essentially, for this part here, you're going to end up with an average. You'll take your different runs and you'll average the volume of sodium hydroxide that you used. And the standard deviation is one thing that's called, or just make sure that all the averages are within this amount of each other. And if all 3 are in that amount of each other, then you can move on. And most likely, if it's your first time doing it, it'll be your first run that is probably the worst, because after that, you sort of know about how much you need. And I'll give some tips for that when we get there. There's no waste container. Oh, let's see, did I finish the one? Yep. So if you need, you can do a 4th and a 5th trial. Basically, you need 3 runs that are within that accuracy, because you're going to be graded on accuracy and precision and correct sig figs. Now, there's no waste container because this is vinegar, and we can put it all down the sink with lots of water. Graders Kevin Diaz. Yes, so for the main thing, that's a general overview of all that we've done. And like I've said, for those who have done this before, probably when I now slow down and go into greater detail for everything, you'll be yawning. I'm sorry, but we're going to get through it. You can speed things up because this is on YouTube. I have no problem with that. But the nice thing is, I don't have to do all this in lab, which means you get more time to do the lab as opposed to however long this turns out to be. All right, so now let's dive into things a little slower now. This here is just going over, it's an acid base reaction and gives sort of an average. It's normally around 4.5%. We're going to standardize it with NaOH. So an interesting fact about NaOH, it comes as a solid pellet, but it's very hygroscopic, which means it loves to suck water out of the air. And whenever you're weighing out sodium hydroxide, especially in Illinois, you put it on a balance and you're like, all right, what's the mass of it? And you're like, it never stops growing. And you'll see this, like the mass on the balance, while you're just waiting for it to finally stop, it'll just keep creeping up because it's quickly sucking moisture out of the air, adding to its mass, which means you cannot create a good standard by just weighing out sodium hydroxide. And so that's why in this lab manual, it doesn't even tell you the molarity of the standard. You're going to end up figuring out just in lab that day what the molarity is, because there's an additional step that has to be done in order to standardize it, to figure out what it is, just because you can't weigh it out and figure it out. But everything reacts in a 1-to-1 ratio, and there's some things it does, again, talk about equivalence point here. It's an italicized word, so it's of importance to know and understand what it is. Phenolphthalein might be the most possibly toxic chemical that we'll be using in lab, since the other things are just dilute acids and dilute bases. phenolphthalein is a great laxative and it can get absorbed through your skin. So please wear gloves and don't handle the phenolphthalein. Don't want you running out of lab. It's pink in a basic solution. And that's true. So it looks pink in a basic solution. So that's why we're going to put our acid at the bottom. Watch the video. That'll be the easier. Watch the person who did it. It's very, very close to what we're doing. Experimental procedures. We're going to take 10 mils of this OHAC. AC stands for acetic. And then the OH is just the oxygen and the hydrogen of the acetic. I know they throw out all these abbreviations. Have there been any others? I guess they do state what the abbreviation is over here. And sodium hydroxide is NaOH. So whenever you see that HOAC, that's the acetic acid, that's the vinegar. And you're going to do 3 trials and repeat until you've got it. Within that, you'll obtain 40 mils approximately of the standardized sodium hydroxide in, it says a clean graduated cylinder. You can just do a beaker because you're going to measure it twice. Like this volume doesn't matter. You're filling it into the burette, and the burette is where you need to measure the exact, or fill it up to an exact amount. For this step, you're just using a container to carry it. I mean, you could use a red Solo cup for all it matters, that has no marks on it to measure it. But, try to keep it close to the 40 mil. So if you have like a 100 mil beaker and you fill it up to the 40 mil mark on that, it's going to be close enough. You don't need a grad cylinder. And then it tells you to transfer it to a beaker anyway. It's an extra unnecessary step. And this is where I learned about Appendix B. Rinse and fill your burette according to the protocol outlined in Appendix B. The nice thing is there's been students ahead of you that have used this burette. And so they've either accidentally left the sodium hydroxide in there, in which you're contaminating with sodium hydroxide, and that doesn't really matter, or they rinse it, and so it's just water. So it doesn't take a whole lot. It shouldn't have large salt particulates dried on the walls of it. So just sort of rinse the walls of the burette and follow the guidelines in Appendix B for making sure that you've sort of flushed your burette 3 times. Now with your burette, it's pretty big, and we don't want to fill it with a whole volume of the sodium hydroxide. And so that's where you're going to take your burette, you're going to put the sodium hydroxide in there, put several mils, enough to slosh it around. Then you're going to take this whole long burette and turn it sideways, and you're going to roll it so that it sort of like coats the whole side. One thing that I realized too, I'm going to stop. Am I still screen sharing? Okay. Yeah, now we're screen sharing now. Let's see. Those are the notes from the email. Done with that. Okay, so let's find. Awesome. This is where like things could be hectic, because if you've never talked about or used a burette, you're like, what the heck is this? So I want to show just a picture of what a burette is. There are these really long glass tubes. These are shorter ones. Here they've almost got the whole burette in the picture right there. And they have a lot of graduations. That's a super fancy one. They've got the stopcock at the bottom. That's the little handle here. And the thing about the handle is the handle knobs are in line with the hole through the stopcock itself. So for this picture on the side over here, since this is up and down, that means the hole in here is up and down, which means liquid could flow through. On this one, where you see that the handle is side to side, that means this hole is side to side, which means it's perpendicular to the liquid, which means nothing can flow through right now. But if it's up and down, it means it can flow through. So you'd want to make sure this is closed. Then you put some volume of sodium hydroxide in there. And then you're going to take this huge long thing and just roll it to sort of coat it. Or, if you put, 4 or 5 mils in there, you could also cap it. This is going to be really weak sodium hydroxide. So you can put your thumb on the end and sort of rock it back and forth. Whatever you do, you'll put some in there, clean the inside, and then dump it out. And then put some more in there, clean the inside, dump it out, and do it one more time. So that's what a burette is. So you're going to clean it, and then you're going to obtain unknown acetic acid in a small beaker, and using a clean 250 Erlenmeyer, transfer exactly 10 mils of acetic acid to the flask. So again, when cleaning things, a good way to clean things, like if you have something dried onto it, this isn't a good way. You got to scrub things that dry on there. But just like with dishes, if you rinse them right away when you're done and don't let things dry onto them, they're pretty good to go. But you can rinse it 3 times with the stuff that you're going to be putting into it. In this case, you could use acetic acid to rinse it, but better than that, just rinse it 3 times with water, because you're going to be adding in step D here, 25 mils of DI water into that anyway. So it's going to be a mixture of the acid and the water. So just take your Erlenmeyer, put some water in it, swirl it, pour it out. Do that 3 times. It'll be clean enough unless there's crud right on the sides. Titrate with sodium hydroxide solution from the burette. So the burette is going to be filled up, and your flask is going to be down here. And here you can see that they're dispensing the liquid into the flask here. I think, did he do a zoomed out picture? Yeah, sort of. Anyway, so he's dispensing it into there. He just swirls it with his hand the whole time in this video. You guys are going to have a stir plate at the bottom of your ring stand, and you have those little pill stir bars that you can put in there. It makes it just a little bit easier. You don't have to keep hand swirling things while you're going along. So you'll put the stir bar in here and have it on your hot plate or stir plate and have it spinning so that it spins it for you. And pipette, volumetric pipette, we already talked about cleaning that. Make sure liquid doesn't get into the bulb. If liquid does get into the bulb, just let me know. And it takes a little bit of practice to figure out the best way to use a bulb, and that's why I use the practice to clean it, as I mentioned earlier. 3 drops of phenolphthalein indicator. That's going to be little dropper bottles, adding that to the bottom, and then you'll titrate it from the solution until it turns a permanent pale pink, and then you'll record the end point volume on your report sheet. And then for part G, it says repeat the same experiment with a second 10 mil aliquot of the same sample. So you just got to rinse your flask 3 times. You can dump it out just down the drain. Rinse it three times to make sure all the old stuff is out. And then it says, since you already know the endpoint volume, you can add 90% of this amount fast. And this is a really good thing just to do on the first one. Like, if you're totally new to this and don't know what's happening, just plan on throwing out your first run and go super fast to figure out about where it is. Just to get the feel of it. Don't think, all right, I'm doing this in such a way that it has to be perfectly recorded. And this is commonly done in research labs. When you want to do something, you do a practice run. And, I did this, I do a lot of woodworking. Instead of working on practicing cutting things on my final piece of maple or oak that I'm working on, I would take a cheap piece of pine and be like, I'm just going to practice on this until I can get the technique correct, and then I'll do it on the real thing. I have no problem with you doing that once again, especially if you're new and you want to get comfortable. Just realize you're going to do a practice run. We got lots of solutions. Do a practice run, and don't worry about perfectly recording everything, just to get a feel of how the burette works, how the titration will work technique wise. And once you do one run, you're going to be so comfortable. And then you can be like, all right, now I know about where the endpoint is. I know what I need to do. And I don't have to worry about like, oh my goodness, is this going to affect my grade? We just threw out the first practice run. And yeah. And then you'll know about how much to add. And then we need 3 good data sets though. So if you are throwing out the first run, just realize you automatically know that you have to do this 4 times. You need 3 good data sets. If you know what you're doing, you just do it 3 good times the first time. If your 3 endpoints do not agree, then you got to do it again. Calculate the average and the molarity and the percent according to the calculations. Boom. So that gets us to the end of things there. Hopefully this hasn't been terribly long. There's the stop button. Stop sharing. I think I've covered everything. So I'm going to stop this video and there'll be a link to that YouTube video that I showed you some snips of, and I'll make another video of doing the calculations.